Hello, my name is Grant Kaufman, and in conjunction with Jimmy DiCaro and Justin Szela, I will be presenting our laboratory symposium. The lab that we decided to do our symposium on was the calorimetry lab, which was lab 7, and it's also known as the temperature to drink coffee lab. And in order to do this lab, we met in person with using mask and social distancing guidelines, of course. Instead of coffee, we decided for hot cocoa and the optimal temperature for hot cocoa. We do not believe this made any drastic difference. We just preferred the taste. In order to do this, we used hot cocoa mitts, an electric kettle, muds, measuring cups, and a digital thermometer. We had to make several compromises. The first and probably most drastic is that one mud we used was different than the other two. Because we did not have three identical muds. One of the muds had a larger volume and surface area than the other two. However, we did use the same amount of water in each mud. We also did not have access to measurement tools that were as accurate as we would have liked, so we had to buy a tool that was accurate, and this was a digital thermometer that we used to measure the temperature over time. We also decided that it would probably be the most effective to meet in person, and so we had to take the necessary CDC guidelines and precautions in this era of COVID.
So then we get to actually how we executed doing this lab. So to make the hot chocolate, we of course obviously needed hot water. Each packet of cocoa required about a cup of water each, so we put 3 cups of water into a kettle and then heated it up and poured them into each of the mugs and then made multiple batches of hot cocoa in doing so. So then we moved on to actually doing the experiment. So immediately after we did that, we immediately started measuring temperature and set a timer for 1 minute and started recording the temperature drop over time. At around 1 minute interval marks, we'd make a recording, and we'd also take a sip of the cocoa to determine if it was too hot to drink or when we were ready to take a decent sip of the cocoa. So we continued doing this and measured the temperature until it was drinkable, and then recorded our temperature where we thought, yeah, this is like the optimal temperature where I'd want to drink it. And then after that, we continued recording temperatures until it got too cold to have a range in which there was a temperature that was optimal to drink the cocoa. So then for our data, our opinions definitely varied. So Grant liked his cocoa a little hotter than Jimmy and I, but overall, it was just basically a matter of an opinion, so not too big a deal. But Grant preferred his at about 54 degrees Celsius, and then it had this 6.19 kilojoules of energy were transferred to the surroundings after that period of time, which is 4 minutes. Then for me, I personally liked mine at 51 degrees Celsius along with Jimmy, but I started at a higher initial temperature than he did, so I transferred more energy overall to my surroundings than Jimmy's cup. So what we actually were able to learn was that we determined our perfect temperature for a hot drink, which was in this case cocoa, and we said it was about 52 degrees Celsius by averaging all of our numbers for what we thought was the best temperature to drink. So we determined 52 degrees Celsius was a pretty good estimate of that number. So we also discovered something completely different from that, which had to do with the rate of cooling, in particular with the different shaped mug. We figured out that the unique mug we used, which was wider, was able to cool the hot cocoa more quickly over time in comparison to the other mugs, which is pretty interesting and not something we were supposed to run into, I guess, but it was pretty cool to figure out.
So we encountered a few sources of experimental error as we conducted this lab. Because we did not use identical mugs, one was wider and larger than the other two, the cups were cooling at different rates. And because we didn't have access to 3 thermometers, we only used the one for measuring the temperature. We weren't able to measure them exactly at the same time for the 3 of them. As soon as we were done measuring the temperature of the first one, we would go straight to the second one and so forth. And the thermometer we used only measured to the ones place. It didn't have any decimal places or the sort, so it didn't have that exact precision that we could have used. And even though we found a average temperature of 52 degrees Celsius among us as the perfect temperature, that is subjective. And if you conducted the experiment or somebody else conducted the experiment, that is most likely going to change depending on the person's taste. And so a few ways that we thought of to improve the lab would be how the first thing we noticed was the simulation exercises in the beginning of this lab seemed very redundant and repetitive. After the first time completing the exercise, we understood the meaning of it and how to do the calculations that we would need to do, but repeating it seemed kind of excessive. And for the instructions, as we were going through them, they were very vague and not as clear cut as we're used to. And though it's good in helping and giving students multiple options for what they need to do and making experiments that are accessible and that students have materials for, it made starting the lab a lot harder because there wasn't a clear path to set, and it caused a lot of confusion amongst us. And because there wasn't a large amount of specificity on how to measure heat transfer, we were having a bit of trouble with figuring out how exactly we should set up our measurements for heat transfer and how we should calculate it and the sort. And if this lab covered more about how the energy is transferred to the cup and how the material of the cups themselves could affect the heat transfer, I think there could be a deeper understanding that could be drawn from this lab. And having access to more precise thermometers would give us a better understanding about the heat transfer because it would give us more accurate data. Thank you for your time.
Yep, thank you.